to you. You got to know it for the pop quiz tomorrow. I just want to make sure we know what all three mean and where they're located on the circle. All right, let's start with the S. Anybody remember from Friday what the S meant?
Angle.
Oh boy.
Arc length.
Arc length, right? That's this right here. However long that arc is, that's your S value. What's that called?
Theta.
Theta. Yep. Theta. And that is what? That is what my angle is. Now be careful because, odds are pretty strong I'm going to do this to you tomorrow. You can only plug in for theta if it's in what?
Degrees, radians.
I guess which one? It has to be in radians. So say tomorrow I give you that angle is 50 degrees. I shouldn't see a 50 in here, but we know how to convert, correct?
Yep.
On the calculator, I can't show you that. And then what about the R? That is the radius length. And it won't be a pendulum. It'll be straight up. Radius is this. Find the central angle, or the central angle is this. But just make sure it's in radians before you plug it in. All right, all good? Because you're going to need that, and you can't ask tomorrow either. All good. Okay, that's not the only question on there tomorrow, but it's one of them. All right, let's hop in here. Where are we? Day 5. Yep. Third and final day working with radians. Final day working with radians here. Hey, a little review here. Why don't we start here? Go around there. Tell me what the degree measures are up on that graph right there. All right, I'll start. 0 degrees right here. What about up top?
90.
90. Yep. Let's keep rolling. Over here. $1.80. 270. And now I'm back at 360. Everyone's good? I go this way, it's negative. All right, give me the radian version now. Do we know how quickly are we getting those now? Because I'm going to add 3 more today. Let's start up here. 90.
Pi over 2.
Pi over 2. $1.80.
3 pi. 3 pi over 2.
I'm just asking 180.
Thanks. 3
Pi.
Pi. How about 270?
3 pi over 2.
3 pi over 2, and then 360?
2 pi.
2 pi. Okay, so those are the ones. Now again, am I ever saying like, hey, you forget this? You can always go to your calculator, remember. I'm not saying memorize it, but just it quickens things up. All right, now back to your notes here. I need you to know 3 more pretty quickly off the top of your head. All right, by the end of today. 3 more pretty quickly, because it's just saves so much time versus going to the calculator. All right, so pi, 30 degrees. You ready for 30? Pi over 6 is 30 degrees. Pi over 6 is 30 degrees. And a quick little trick here. Pi over 6. What's pi again?
180.
180 divided by 6?
3.
30. Okay, so the pi is always 180. What do you think 60 is going to be then if you already know pi is 180?
over
Pi
3.
divided by 3.
Oh.
Studs.
Yeah. And then what do you think? Ooh, 45. Pi is equal to 180.
Pi divided by 4.
Pi over 4. It is okay, and I prefer that you flip back and forth from your paper today to get these. All right. All right. Here's what we're going to do today. We know how to find a reference angle. Hopefully, we know how to find it. So what I'm going to do today is I'll give you the reference angle in the quadrant. You tell me what the original angle was. Okay. So I'll tell you the reference angle and the quadrant. What was the original angle? So we'll take a peek at this first one up here. Theta r is the reference angle. So the reference angle is pi over 6. Quick, if you got to flip back.
30.
30 degrees, right? 30 degrees. And I'm in quadrant 4. So what was the original angle? So can we first draw that reference angle? All right. Reference angle on the x or the y? Reference angles are always on the x-axis. And we're in what quadrant again? So I'm going to draw a 30-degree angle in quadrant 4 right there. So there's the reference angle, 30-degree angle in quadrant 4. What I want to know is What must have been the original angle? Don't yell anything out. And you better be giving me an answer between what two angles if we're in quadrant 4? 270 and 360. All right, think about it. If you know that's 30 degrees, and I want to find the actual angle in the 4th quadrant, what calculations can I do here to get that angle?
Minus 30.
What?
90
Oh, well, no. You should not ever be giving me 90 or 270 out of your mouth, right? Because that's on what axis, Owen? Okay, I need something on the x, right? So you're either using 180 or 360 every calculation. All right, you do not use 90 or 270. We never use those calculations. Anybody think they got a way of finding that actual angle? Leah, what are you doing?
360 minus 30.
360, yep. So here you go, everyone, 360, because if I go all the way around and stop here, it's 360, minus the reference angle that's already there, 30. So what's that angle in the 1st quadrant, or the 4th quadrant? 330, yep. So that angle is 300, must be 330. Ooh, hold on though, we're not done. We didn't follow the directions. Find the angle in radians, then write the angle in degrees. Well, I already got the angle in degrees. We're good. Don't touch your calculator. We're going to do this without using your. You can if you need to on your own, but watch how quick this is going to go. You ready? My angle was pi over 6, right? Which is what in degrees?
30.
Everyone right? 30, pi over 6, 30. How many 30s go into 330? If you got to use your calculator now, use it, that's fine. How many 30s go into 330? And watch this magic. How many 30s go into 330?
11.
How many?
11.
How many?
11.
11 pi over 6. There it is in radians. Just pi over 6 times 11. All right, so that's all I'm going to have you guys do to find the radian version. We don't need the conversion on the calculator. Ready? Everyone all right on that? One doesn't make you great, but I'm going to start calling on people now. Part B, pi over 3. What do you got for me? Pi over 3. Pi over 3. 60. Hey, and even if you forget, what's pi always equal to? So just do 180 divided by 3. That'll always tell you. Remember that. Okay? If you forget what the quick conversion is. And now we're in quadrant 3 now. All right, let's take a look at what this one looks like. Short day today. Short day. X-axis going into quad 3. That angle is 60 degrees. I want to know what the angle is in quad 3. What should your answers at least be between? 180 and good. 270. At least we're in the right spot. So what is that angle right there? That's what I'm looking for. Right? We don't want to stop here because that's 180. We want to go further. All right, I'm going to ask somebody here for a calculation. How can I find that angle? It's got to be between 180 and 270. Who's helping me here? Start us off right. Who's up here? Ian?
210.
How?
270 minus.
Whoa.
Or is it the other way? Oh, wait. I did it.
Killing me.
Why?
Is everyone good?
Yeah.
Never use 270 or 90. All right, reference angles are on the x-axis, not the y-axis. So what do you want to do here? Well, ready? Here you go. I go from here to here. How many degrees did I just go?
180.
But I still need to go another.
60. Oh. 240.
Oh,
Oh.
even the stud's having a little trouble here today, huh? 240, everybody good? 240? All right, ready? No calculator. What is 240 in radians? Well, we said it was 60, right? How many 60s, pi over 3, how many 60s go into 240, Gianna?
4.
We're done. Okay, does everyone see how I'm doing that so quick? I know pi over 3 was 60. How many 60s go into 240? There's 4 of them. And look, if you're unsure, just convert it on the calc like I showed you last week. Good work. Good work. Anything? We're still good? All right, another quadrant 2. All right, so everyone draw that reference angle in quad 2. That's pi over 4. And you're trying to find the angle in the set. So at least it's got, here we go again, it's got to be between what at least? 90, a buck 80. How do you find that angle? And when I use theta, that's just the angle. Again, that has nothing to do with the SOAR formula from Friday. It just means the angle measure. All right, so how could I find that one? Oh, and you got a suggestion? 180 minus. Oh, I should have went over that. I don't want. Remember, and I'm glad Owen did this. I'm glad he did this. Never do adding or subtracting with a degree and a radian. They got to be both the same here. So what was pi over 4 again? 45 degrees. Yep. So 180 minus 45. You got that, Owen? $100 and. Oh, I thought you got it for me. 135. And then what is it in radians? Let's see. Well, I had pi over 4. How many 45s go into 135? 3 of them. So there's the quick conversion into radians. We're almost done here. Anything else? Ask away here. If there's something else you want to ask. All right, what else here? All right, sketch the angle. I say no calculator, but if you need it, you can always use it. I'm not going to take it away from you. I love this. I get so fired up when I get to do this. All right, first one is 5, graph an angle of 5 pi over 6. No calculator, ready? Pi over 6. If you got to look back, don't yell out anything. Pi over 6. Pi over 6, pi over 6. That's a quick one here for what degree measure? Pi over 6. Ian, pi over 6.
Oh, jeez. Whoa. Pi over 6, 30.
30 times 5.
150.
Done. 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 All right. You don't even look. That was a heck of a lot quicker than. Which way do I go? Arrow. Got to go to radian mode. Where's my degree button? Where's my rad button? Done. 150. All right. You don't. Come on now. If we don't know how to graph 150 here, you can leave the room immediately. All right. 150. What quad am I in here? Well, Jesus. 150. Amron. 150. What quadrant? Don't do this to me. What's up top here? 0. Yeah, I know it says no calculator. Thanks. 90. What's here? Okay, let me ask again. Where's 150 going to be? What's that? Okay, closer to 180 or closer to 90? Okay. And still missing something. Not going to get full credit for that graph yet. What's it missing?
Arrow.
Arrow, yes, it's missing an arrow. Yeah, some of you guys are missing arrows on yours. All right. Everyone good so far? All right, next one. Negative pi over 4. No time to go to the calculator and convert. What's that automatically going to turn into? One of them that we should know right off the top, hopefully, Joe. Pi over 4. 180. Go back to the note. Go back to the beginning here. Go back to the beginning. Pi is 180, but then I'm dividing it by 4. 45. Again, remember, pi is always 180. So you can always take 180 divided by whatever number is on the bottom. Do I have to turn it into positive, or do we know what quadrant we should be in here if we're going negative 45? Oh, should it be, Tyler? Should it be? Negative now. Negative, going in a different direction. Ian, come on, save yourself here today.
45 degrees. Negative 45. What's that?
I just want to know what quadrant I got to
Oh.
draw this in.
One, the first one.
Oh no.
Well, if it's negative, it'd be the first one.
It's not
Because it's
stunning.
going backwards. The fourth one?
And that's what I'm asking. What quadrant
The
should I
fourth
draw?
one.
You sure about that?
Yeah.
Okay. Yes, it is. It's the fourth one because I'm going backwards. So that's negative 90, right?
Yeah.
Where is it closer to?
It's in the middle.
Oh, okay.
Yeah, it's in there.
Yeah, I thought like if it's negative, then it's bottom right's
Backwards.
1 and bottom left is 3.
No, quadrants are always the same one.
Okay.
It's always 1, 2, 3, 4. It's just a matter of which direction we go. Yep, quadrants never change. Whew, we all right? 7 pi over 3. So I go to myself, all right, what's pi over 3? 60, right? 60 times 7. Ooh. 420 degrees. Good. Is this as funny as our sigma? So we get that out. No, we're good. Okay, just asking. All right. Okay, yeah, I don't deal with something bigger than 360. You know that. So subtract 360. Yep, subtract it. So I'm looking at this angle is going to end where the same place as. That's what I was thinking. 60.
Yeah.
All right. Yep, it's going to end the same place 60 does. Where does 60 end? What quadrant does 60 end in? Oh, Amber, let's go. Come on. Where's 60 end in?
Quadrant
2. There's 90. There's 180. Quadrant 1, closer to 90 or 0? Make it closer to 90. The only thing where you got to worry about when you do your arrow, you can't stop here, right? Because if you stopped here, that's just 60, right? All the way around, then stop. Oh, not done. I didn't notice this till right now. We had to sketch it and then what? Find the reference angle of each of these. Oh, whoa, yeah. Ready? Let's go back. And then see if anybody notices a pattern. This angle is what, $1.50 we said here? What's that angle then? 30, which would be what in radians?
2. Pi over 6.
Pi over
6.
Oh, that's interesting. The angle was 5 pi over 6, and the reference angle was pi over 6. That's interesting, huh?
Interesting.
Everyone ready for this one? For the negative 45. What's your reference angle here?
45.
Right, here's your reference angle again. Is your reference angle 45 or negative 45?
45.
Why do you say 45?
We don't do negative.
Reference angles can never be negative. Look at you guys. Yep, so it's 45, but in radians, what would it be? 45.
Pi over 4.
Anybody notice a trend here? Given your actual angle, what the reference angle would be? What about this last one, 7 pi over 3? What would be my reference angle here?
60.
Right here, 60, which is also the same as? Okay, you guys seeing what I'm talking about here? How can you tell just by looking at the actual angle what your reference angle will be? 5 pi over 6, it was pi over 6. 7 pi over 3, it was pi over 3. If I give you 125 pi over 6, guess what the reference angle is?
Pi over 6.
Pi over 6. Okay, so I could just detach that number from it. All right. And then final one here before you get going on your own. I don't even want to graph it. State the quadrant and find the reference angle. All All right, first question to somebody, what is that in degrees? Because I can't find any quadrants and radians, only in degrees. I don't want to convert it either. I don't want to convert it. I don't want to convert it. Here we go. Ones. Nick, what's the pi over 6? Tell me.
That's 30 degrees.
30 times 7.
210.
Done. That angle's 210. All right, keep going, Nick. What quad am I in then?
3.
Quad 3. Good. Look how quick this is going. And how much you're understanding in this amount of time. What about the reference angle? I really don't want to draw this. Reference angle, if I had 7 pi over 6, must be
5 or 6.
80.
Oh.
80.
30.
30, which is what in radians,
5 or 6.
right? Like we talked, 7 pi over 6, detach the 7, you got the reference angle. All right, over here, negative 2 pi over 3.
60.
60 times negative 2.
120. Negative 120.
Yeah, this is negative 120. You do what you got to do to tell me what quad it's in. Some people can handle negative 120. Some people need to add 360. I don't care. Handle it, though. Handle it. I need to know what quad negative 120 is in. 1, 2, 3, or 4. And don't make it a guess. Where are we going there? Tyler?
It's in quadrant 3.
It is in quadrant 3. Good work. Same as 240 if you added 360. And finally, let's talk about the reference angle without having to graph it. If you got negative 2 pi over 3, suggestions on what the reference angle is?
Pi over 3.
Negative pi over 3 or just pi over 3?
Pi.
Just pi over 3 because it has to be positive. Okay, just pi over 3. All right, questions? You got 1 page, that's it. 1 page, and I'm going to put the answer key up here so you can check yourself. 1 page. Please look up here for the answers to make sure you know you're doing it correctly. What's today?